Differentiation from first principles uses the theory of limits. I have chosen this particular problem because this is one of the 3 general types of problems that you need to prepare. I've already done the first one in another video, so if you look into my channel, you'll be able to retrieve that video, and also I'll put a link to it at the end of this video. This first type of a problem was about differentiating from first principles normal functions, such as polynomials. The problem we have here is an example of a differentiation problem, and it is an example of differentiating a reciprocal functions, where you have 1 over x. This is what we call a reciprocal function. And the first step of writing this is really quite simple. First of all, we write down the original function. This describes the coordinates at a point x. And I've attempted to draw a little diagram to show you this, where if at point x we have fx, and these are the coordinates there. Now the next stage that we need to do is to write f, but this time we're going to use x plus h, and that will be 1 over x plus h. The x plus h is another point on the line that I've drawn in yellow. So this is the point x plus h, and the y coordinate is fx plus h. The coordinate will be where h is supposed to be that slight distance from one point to the other. So the gradient now of those 2 points will be shown here by blue, and our next step here is to show that gradient. And as you know, in simple terms, the gradient is just the difference between the y values over the difference between the x values. And so to find out the derivative function, which we'll design as f dash x, we're going to have to decrease that h value to 0. So as these 2 points come closer and closer together, we will get, showing this formula is critical. And now we'll substitute the 2 functions into that formula. So anything on the left hand side is the one that gives you marks. The right hand side is just my information. And so now I'm going to substitute 1 over x plus h, take away 1 over x, and this is all divided by h. So at this point, if I let h be equal to 0, then my whole equation will be invalid. So I need to rearrange this equation. Now my numerator seems to be very problematic, so I'm going to start with the numerator first of all and rearrange that. I'm going to cross multiply the numerator, so I'll get x minus x plus h, and that will be divided by x plus h multiplied by x. And we still need to add that h in the denominator. And so our numerator now looks not too good. Let's start doing a little bit of rearrangements, simplification. So now our numerator looks like this. Is that any better? Well, I think it could be better because I'm going to delete this x and that x away. If I rewrite this again, I will have negative h over x squared plus hx. Now the h in the denominator, what I'm going to do with this is, because it's divided by h, I am going to multiply it by 1 over h. on the sidelines, because if I have an A divided by a B and I divided by H over 1, then that is going to be the same thing as saying A over B multiplied by 1 over H, where A over B is our working out that we did in the numerator. Now, it's important that you actually do put 1 over H here, because now we can cross out the H and cross out the H. And a lot of the times, students don't realize that there is a 1 left behind. So now, at the end, we have a minus 1 over x squared plus hx. Now, I'm trying to show you some of the pitfalls that you might go into. So once you're comfortable with all the steps, you may want to miss a few lines here. The last line that we have is the one now when h becomes 0. We make h equal to 0. So this is still f dash x, because I can't see the top. So in that case, f dash x now is equal to, no more limit and h becomes 0. We make the h 0 and we're left over 1 over x squared, because this now becomes 0. And so we were able to prove that f dash x is equal to minus 1 over x squared in here. So there are 6 marks over here, and the 6 marks will come from 1, 2, 3, 4, 5, 6. These particular equations and this method over here, which goes all the way up to here. Brilliant. I hope you found that useful, and if you did, then please subscribe to this channel and gives me a thumbs up.